Hi everyone, thank you very much for joining. In this session, we're going to talk about managing observability in modern applications and especially in Kubernetes environments. So nice to meet you. I'm Ribenzaft, the co-founder and CTO at Epsagon. I'm also an AWS serverless hero, which means that I really like serverless and like having managed infrastructure as much as possible. In the picture here, you can see me looking for whales in Hawaii, but unfortunately, I couldn't find any. And you can follow me on Twitter, RunRib. I'm talking a lot about Kubernetes, about serverless, about cloud, anything interesting you can find there. So let's get going. Today in the following session, we're going to talk about monitoring and logging, kind of in the old era and how it shifted towards the way we're doing Kubernetes and distributed applications. I'm going to drill into observability and understand more what it actually means. And I'm going to drill into specifically distributed tracing, which becomes the core component today in such applications. So let's get going. First question that I love to start my presentation with. So, why are we even monitoring? Why are we bothered about it? So many people might say because we need to make sure the latency is good or the requests are coming well. But honestly, it's just to make sure that our business is working properly. Because in most cases, for most of us, the application that we're building really defines our business. And the way we do it better, the way our application will impact our business. So we're doing it for the business. And the things that we'll need to look for when we're monitoring our applications defined really well in the Google's SRE book for distributed applications. The 4 golden signals that each and every one of us should take a look at. And let's review them quickly. First one is latency. How long it takes for a customer, for example, to get a response from our website or from any operation that he makes. This is super crucial because that defines how fast is his interactions. Also, the amount of traffic. We need to understand over time how much traffic our services get to know whether we need to upscale or downscale or just have a better understanding what's going on. We also need to look about the errors because errors are obviously not good. So we need to look at over time what's going on, what's the impacts, what's the percentage of errors that we're having, and whether it's a spike or something more of a trend. Ultimately, another thing to take a look at, many people miss this out, is the saturation or how full is my service. This gives me the picture that even if everything goes well, maybe my system is at 95% load and it's very soon that it's going to to explode and not react as we need. So saturation gives me another golden signal for that. Now, in order to get this kind of signals or monitors, usually in the old kind of monitoring, we had on the right hand side the server, a REST API, and it would talk to some database. So we would need to place an agent, a binary that we would install on the web server, and it would collect the host data, for example, CPU and memory and disk and network and so on. It has only inherent limitation, which is actually the fact that it collects just metrics. I mean, if there is a problem, it wouldn't tell me what exactly is the problem. It would just give me a set of symptoms, a set of like a data set of metrical data that I can understand or correlate to something in order to get the problem. And actually to troubleshoot the problem, we need something more than that. We need the debug data or the logs as we're calling them. This kind of logs, now this agent got another friend next to him that usually export the logs, collect all the logs from all of the services and export them somewhere. In the old kind of traditional application, it was usually to local. So we would SSH to the web server to understand exactly what's going on. But in kind of a bit modern days, we ship it to somewhere remotely to a centralized logging solution. So that's a much better approach. And it has another inherent problem that it collects only the log that we tell him to log. For example, if in my application I'm not logging some information, it's just not going to be there. Nobody is going to collect logs for me. So it has some limitations to itself and another agent on the web, on the server that we got. So let me take you fast forward into the future. In the future, we're talking more about managed applications, microservices, cloud, orchestrators. It's pretty clear for everyone today that a new application will be built on Kubernetes, on serverless, on cloud, managed resources, and so on. This is almost a fact today. And when we're thinking about what the new kind of applications are looks like, uh, we had two main parameters: where it's running and how the application is being composed. So we started from the left side, with host-based and monolithic applications, and over time we broke down the application into a more distributed applications, which resulted in some complexity, but it was still maintainable. And then we moved into, abstracted host running on cloud, third-party APIs, managed resources, and much more distributed and event-driven. This is, really and extremely impacts our way to monitor and troubleshoot these kind of applications, which leads me to the fact that, we're getting new challenges today. Although we have a lot of benefits, there are new challenges coming up, especially for the engineering and DevOps when we're talking about it. First one is troubleshooting. We used to log into a server and look at some logs. It's long gone. I mean, we can't do this anymore. We need to correlate logs between different services, understand the journey of our user across all of our services. This becomes much more pain today to troubleshoot and get into the root cause of a problem in our system. Secondly is the monitoring. How do we know what exactly services are talking to one another, and where are our bottlenecks, and what's going on in our cluster? This has become something that is really hard to visualize and understand, especially when you're getting more and more complex. And actually, this too also impacts our development. So if we're not doing this well, we're going to get, lower or slower developer iterations and much more time on debugging stuff on dev. So we really want to focus on, ship faster. So if we're doing this kind of troubleshooting and monitoring good on production, it will impact our development lifecycle. I think that now we can ramp up and speak about a broader term. Instead of just monitoring and logging, let's talk about observability and understand what exactly it means. In observability, we got three pillars: metrics, loggings, and traces. Metrics are the ones that we're collecting, CPU, memory, disk, network, and so on. And we aggregate into a singular place usually to get a better view of the vital signs, the way I like to call it. Now, when we have a problem, we need to dig into the logs, as we already saw. And usually, by the way, these two are different tools. Like you have a tool for monitoring and you have a tool for logging. And the third part of observability, and the one that we're going to really dive into, is tracing, because this really helps us understand complex systems. Otherwise, we will just look at each and every resource individually instead of having all of them scoped and correlated together. And especially when we're talking about modern kind of observability, you want to have all under the same dashboard or the same platform, rather than have 2 or 3 or 4 different tools that covers each aspect differently. Now, before drilling into tracing, I want to cover some of the best practices, both for logging and for metrics and monitoring. So for logging best practices, I can't put it in a more serious way: log only structured logs outside. It means that if you're having a phrase that you want to log out, just make sure it's part of a structured JSON or dictionary that includes more metadata information, like the service name, the stage, the user that was being handled, some more information that will be able to get you to the right log more faster. And also try to automate as much the process of logging. As we understand from previous slides, logging is manual, and the more you do it manual, the more you get stuck and you forget things and things are missing out. Try to automate and with middlewares or other things so you'll get it much faster, and make sure to index the fields that you're interested in, because that would give you a way to aggregate, visualize, and understand trends in your applications. Second comes the monitoring best practices. And I think, again, this goes without saying: aggregate all of your metrics into the same dashboards. Your metrics from Kubernetes, from your cloud, from your application, every metric should get into the same dashboard, to a unified dashboard, so you'll be able to query and understand all of them together. And also, again, this is super important: define your critical metrics, or in other words, set thresholds. If you're waking up in 3 or 4 a.m., it's better worth it, because otherwise you're not going to wake up. And it means that if you need to set up a threshold of the percentage of errors or the kind of errors, make sure you're doing it. Otherwise, it will create an alert fatigue and everybody will just ignore these kind of errors. Ultimately, try to ship some custom business metrics. As we understand, monitoring is in order to make our business better. And if we can collect things like that can impact our business, and I'm going to talk about it in tracing, it becomes super helpful. Also, make sure when you're monitoring, monitor your application as well. Many people think that, okay, I'm monitoring my service, my like servers or my orchestrator, and everything seems well, so everything is working. So it's not that good. In the application, you probably want to look for the average latency of calls, like how long it takes for a service to reply, or maybe the minimum number of messages in a message queue to understand how much throughput you're having in your system, or even just the most classical one, the 400 and 500 errors, which can indicate in some problem in your application. Also, specifically for Kubernetes environments, you have a set of tools to collect, store, and visualize these kind of metrics, starting from Node Exporter and cAdvisor that will help you collect from the containers to the node all of the information that you need, and then Prometheus and Thanos, which will help you aggregate all of this information, ship it somewhere, set alerts, and so on, and ultimately visualize it in a unified dashboard that can get from these services and others as well, like Grafana and Kibana. All of these are open source tools, so you can get started with them for free and now. And I think just covering some of the aspects that you need to look for when you're monitoring a Kubernetes environment. So starting with pods and containers, understand the resource allocation and the usage, understand exactly what's going on inside the container itself. Also in nodes, I think that it adds up to understand the disk and network, because nodes are they have their own limitation, the maximum limitation that they can handle. So looking at this is also important. And in the cluster, I would look at the overall state and health. I would look at the request and available CPU and memory, because this is the point where we can no longer allocate or provision more pods or containers on our nodes. Obviously, there are much more to this, but this is just a glimpse of what would they do in a Kubernetes environment. With all that saying, I think that something is still missing, something very crucial. First thing is, how do we monitor between metrics and logs? So logs are going one way and metrics are going the other way. Now there is a problem. Let's say Prometheus alerted me that some pod is not working properly, but now how do I know exactly what's not working? What should I do? So I need to jump into another tool to understand the logs. So this is one problem that is still missing. The other one is, how do I correlate, for example, if I'm having an exception, how do I understand the overall flow that led to this problem? Because I know that when a user sign-ups, it goes through 7 different services and just one of them failed. But what about the other ones? What exactly led to the problem? Or even a performance issue, how do I troubleshoot it from end to end? So something is still definitely missing, which leads me exactly to the distributed tracing topic. Distributed tracing, in very short, tells me a story of how a request propagates through my system. My system, like in this example, can be a client, load balancer, auth service, billing service, and another resource. And honestly, all distributed tracing does is to tell me, okay, your request started from the client to the load balancer and then to the auth service billing. This is how much time it took at each and every service. And it composes all of this, asynchronous and different services that are doing some handling into a one set of a story. In order to do distributed tracing, we need to do two main things. The first one is generating traces. It means that we need to collect the information just as we're doing with logging, but we'll talk about some of the benefits doing it with tracing. And the other part is the ingestion and the client. We need to take these traces somewhere and visualize them and do something with them. So I'm going to refer in this presentation to Open Tracing and Jaeger, but just as you know, we got Open Tracing and Open Telemetry for generating traces and metrics on top of them, which are part of the CNCF. And we also got Jaeger and Zipkin or Open Zipkin to get these traces and visualize them. Jaeger is also part of the CNCF, the Cloud Native Computing Foundation. So let's start first with generating traces. In order to generate traces, the first thing that we need to do is to instrument every call that we're having. Think of it that way. You're calling some SDK, some HTTP call, some Postgres database, or you're getting an incoming request to a Spring, to a Flask or Express. First thing that you need to do is to automate the process of collecting the traces or interfere in the request response mechanism. So for example, let's say I'm making an HTTP call. I need to hook myself into the request part to get some information about what am I calling, what URL, what parameters am I sending, and so on. And once the request is coming back, look at the status code, look how long it took. So, collect some of the information so I'll be able to generate a trace. So this is start with the first thing that's called instrumentation. The second part, and now comes the open tracing terms, is to create a span. A span defines, an operation on some resource, and it has some time. So we know, for example, we made an HTTP call, which can be GET, POST, or any other operation, to this endpoint, for example, the Stripe API, and it took this amount of time. So this is where I'm creating a span. To that span, I want to add some more context, because just telling POST to api.stripe.com and this kind of information, I want to elaborate it more. For example, what was in the response status code, or what was in the headers, or which user am I charging? Add some more context and tags to this span. And ultimately, I need to inject and extract IDs. This is really boils down to the distributed part of the tracing. So let's say I'm making an HTTP call from service A to service B, which apparently both of them I'm owning. So when I'm sending this HTTP request, I need to inject some magic header, like something in the HTTP headers that will tell anyone out there that is listening, that now you're part of trace 1 to 3 or trace X. So when service B comes and get the request, the incoming HTTP request, it will extract that magic header and it will say, oh, I'm seeing that I'm already part of a trace. So I'm going to continue this part of the trace instead of starting a new one. So this is inject and extract. Obviously, it gets much more complex when it's not HTTP, it's message queues or managed services. It's getting harder and harder. Just so you'll be aware, as an example, this is in Python, for example, for Flask or Django. This is the part of the instrumentation where we need to inject ourselves into the handling of the request. And then we start by extracting from the headers whether we are part of a trace. We're starting a span with this information. We're adding some context by setting tags like HTTP URL or remote IP or the caller name, some information that will give us some more context to it. And again, this is just one example for just the incoming request of a web server. Instrumentation takes a lot of time, and I'm going to refer about it at the end. Now, after we collected these traces, we need to somehow ingest them and have a client that will visualize them. So first thing that we're thinking about it, what's our ingestion scale looks like? Is it 1 million of traces per day? Is it billions of traces? How much traffic are we going to get and we need to store? So this is something to bear in mind. Also, when we're thinking about this kind of client, we're looking forward to have something that can index our context for easy search. So, if I'm indexing the user ID that I'm handling, I would like to pinpoint it. So when this user is having a problem, it will be easy for me to search, or even just to aggregate this kind of information over time. How many requests does this user have in my website? Also, I need some way to visualize this kind of traces, either in a timeline that tells me how long things takes, or even in a graph view that will tell me this is the story, just as we saw in the first part of distributed tracing. I also want something that will tell me, hey, we found out an alert over here that will get me to my Slack or my PagerDuty and so on. And there are lots of more things that I can think about when we're talking about ingestion and clients. And in this example, Jaeger does a really nice job. It will get the traces and visualize them for you. As we can see over here, a request coming from the front end with the, all the Redis calls that we're making in between and the errors that was being captured. This really tells me a good story. However, Jaeger is, first of all, a self-managed service. It means that you need to handle the scale. And also it doesn't contain any alerts or graph view or any sophisticated or advanced features. It's just about visualizing a timeline out of it. Few things before we dive into the demo that I would like to cover with you on the best practices of distributed tracing. First and foremost, it's super important to tag your traces. Tagging traces will help you both in pinpoint a problem or just understanding some trends and aggregations in your system. So first thing that I can recommend, put identifiers into your traces. Things like user ID, customer ID, device ID. These things will help you troubleshoot and pinpoint things much faster than before. Also look at the flow control to understand things like how many times am I handling this kind of event type, or how many times am I doing this kind of business logic type. This will help me understand, if I'm looking how long on average it takes to upload a post or get a post in our system. And ultimately, as we spoke before about business metrics, things like items in the cart or minutes watch will be super helpful for engineering and product teams to really understand how the business is operating more than just whether the application is working good or not. After taking traces, let's take it even one step further. Why shouldn't I put all of the information in the trace, like everything that comes in and out, into the trace? Things like, instead of picking just the user ID or some IDs out there, let's put all of the information from the HTTP call, headers and body and payloads and parameters, all into the trace. All of them will get indexed, so it means that I don't need to manually tag my traces. Also, for example, my key or my query, when I'm doing an operation to a SQL or NoSQL database, think of how nice when I'm having a problem in my SQL Postgres database to look at, what was the exact query, or understand over time how many times am I calling to this specific key on the NoSQL database like Mongo. Also, maybe just capture all of the information, like the response payload that I'm sending out to my user from my web server, so you get it. Collect all of the information from end to end, and it will just automate the process as much as possible. And ultimately, tracing can act as a glue. Trace can tell us, first of all, where the logs are. So instead of having a different solution for logs, collect all the logs as part of the trace, or just point from the trace where the logs should be sent. Because if they're being sent to Elastic or Splunk or some other service, I want to be able to get from the trace to the log. And from trace to the environment. So if this trace is running on Kubernetes cluster, I want to understand exactly which pod is it, or if it's running on another orchestrator, or if it's running on serverless, or if it's running on any kind of environment, I want to be able to see that. And vice versa, from the environment, I want to be able to see all of the traces that I'm having. So this is really acts as a glue between all the different pillars of observability into the same kind of pattern. Now, before we dive into the demo, I would love just to briefly describe what would be the best practices for observability, or what a good tool should look like when we're doing observability. So first and foremost, it's all about the automated of this kind of approach. No setup, no maintenance, no training. Think of it that way. If your engineers are now need to put some more focus into observability, it means that they're not working on what they should do, and that's not good for the business. So automate as much as you can with this tool. Second, this kind of tool should support any of your environments, whether it's running on Kubernetes, on cloud, on serverless, any kind of environment should be supported. And it should tell you a full request from end to end, whether your requests are going through gRPC, HTTP, message queues like Kafka, Rabbit, SQS, and so on. You want to be able to see the story from end to end, a real end to end. You want to be able to search and analyze your data, everything that comes within the traces, aggregations, pinpoints, everything should become very easily. And also it should help you reduce your time to troubleshoot. This is the right kind of solution that will reduce your MTTR, with the right term, or just understand exactly what's going on from end to end. Now let's jump into the demo. So our demo environment that I'm going to present is available for everyone. You can get it now, demo.epsagon.com. I'm going to focus mostly on the Kubernetes part, but it also supports serverless, ECS, Fargate, AppSync, and more. Starting with the Kubernetes clusters, you want to be able to get an overview of what's going on in your cluster or set of clusters. And today, the most straightforward approach is to set up your own Prometheus, scale it, have a persistent data store. It takes a lot of time, and instead of it, a solution like Epsagon gives you all of it out of the box. So you can easily see all of your clusters, exactly what's going on in terms of the usage, request, limits, and available both for CPU and memory. Same applies for nodes, pods, containers, and deployments. So for example, for containers, we can see all of our running containers. If we're interested in seeing the logs, as I mentioned, a solution that brings you metrics, logging, and soon we'll see traces. So something that will be visualized for me, all of my logs as well. So I can click on any kind of logs to actually see what happened in this specific service. And in this, for example, I can see exactly what's going on. And even just to visualize, what's going on inside my pods, which are the most important one, disk, CPU, memory, network, understand exactly what's going on is super important. And actually I'm interested in drilling into a specific one of them, which is the stock updater. This is one of my main applications. I got a retail website that I'm handling right now, and it's doing a lot of order services and updating the stock. So I'm interested in seeing exactly what's going on in the spikes of the CPU or the memory, or exactly what's going on in the network, or actually just understand what containers are running there. And now let's drill into the traces themselves. With a good solution, I can jump between the environment and the traces. So this is literally takes me to another screen, which called the traces search. And it tells me, let's look for everything that this pod was specifically part of. And with a good solution, it brings me both the aggregation data, for example, how long it takes for requests to being handled or how many errors and success there are, but also it will show me the all requests that are part of it. Everything that ran as part of this node, my Java consumer application, any call that I'm making to any service will be listed. If I'm interested in troubleshooting this error, usually with loggings, I just need to correlate between different services. In this example, I'm just clicking on this exact call, and I'll be able to see a full trace from end to end, which will tell me exactly that I got an incoming request on my load balancer, and then it went to my Spring web application through a Kafka queue, then to another consumer, and then doing some communication to DynamoDB and S3 bucket. So this application is running on top of Kubernetes, on top of AWS. And in this example, we're seeing that we're having some issues. We've failed to connect to some host. I can see exactly what happened. I can do a root cause analysis by going backwards, for example, understand what exactly was being captured on the Kafka message, like exactly to understand which username was affected or what discount code was it using. So everything is visible for me to understand exactly what went in this specific operation. And also I can visualize it in a timeline to understand exactly where am I spending most of my time, or even it's in between the services, for example, calling the Kafka to produce a message and until it takes the time to consume it. So that really gives me a good overview and understanding of what's going on. Once we're done with the traces, we sometimes want to look at the overall architecture, not just a single application, not just a single trace, but the overall application. So this is our overall application, and in here I can see exactly how each and every service operates, how many errors does it get, and even just to drill down to understand in terms of performance-wise, what exactly is going, in terms of the errors, success, call durations, everything that we talked about, the 4 golden signals, will be visualized in here to any time frame that we want, to any service, to any cluster, and any pod. Ultimately, what I would love to finish with is, sometimes in this kind of environments, we have a lot of issues and we need something that will help us get and be on top of them. So the issues management really gives us a one-stop shop for every exception that happens, any issue, understand how frequent it happens and whether somebody is on it or not, and even the ability to mute it, which actually leads me to the fact that once there is a problem, you want to get notified. And it can be either on a pod issue or an exception or a threshold, like as we spoke about in the best practices, and get this issue anywhere that we need, Slack, PagerDuty, and so on. So that was the demo environment, and you're all more than welcome to get in. I think as a quick summary to end this session, so we understand that modern applications, ones that are running on Kubernetes clusters, become more and more complex, and it's just not enough to do monitoring or just logging in the different solutions. Distributed tracing becomes a much more crucial component in such environments to understand the overall end-to-end and understand how can we troubleshoot faster and operate much faster. And I think as a quick tip for you, everybody in home, I know that there are lots of open source. Think very good before you jump into do-it-yourself and implementing your own solution, because it will require a vast amount of effort, and that's not what you really want to do. You want to focus more on building your application, moving your business faster. So when you're doing it, please compare it to existing solutions out there. I'm welcoming everyone to start your own free monitoring for your Kubernetes cluster with Epsagon. We provide free monitoring at any scale, at any amount of clusters that you're having, you'll get monitoring insights and alerts for free for your Kubernetes cluster, and some extra benefits in the following link. So you're more than welcome to get in now. Thank you very much, everyone, for joining